Welcome to EC Elimu, Learning Simplified, and welcome to this lesson. In the previous lesson, we discussed electrostatics and we looked at the meaning of the title electrostatics, where we said it is the study of non-moving electric charges, which are found in the outer surface of the smallest particle of matter, which we called an atom. Then we moved ahead and talked about the structure of this atom, where we said an atom is made up of two main parts. We have the inner smaller part, which we call the nucleus, and then we have the large outer part, which we call the energy levels. Then the nucleus, we said it has two subatomic particles. It has protons, which are positively charged, and it has neutrons, which its charge is 0. Then the energy levels, we said it has electrons, which are negatively charged. Then another important thing that you should note here is that the number of protons which are positively charged is equal to the number of electrons which are negatively charged. Another important thing that you should remember before we continue with this topic is that if you interact with a material, any type of matter, either solid, liquid, or gas, whatever you are interacting with is the subatomic particles which are found in the outer part of an atom. In this case, you will only interact with electrons. So when we are going to have our charges, or when you are going to charge a material either positively or negatively, the only thing that we are going to change is the number of the particles which we can interact with directly, that is electrons. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to state and explain the types of charges. In this case, we are going to look at the positive charges and the negative charges, and then explain the electrostatic charge of materials, and then finally explain the electropositivity and electronegativity of materials, where we are going to categorize materials which can lose electrons easily and those which can gain electrons easily. So we have two types of charges. First one is a positive charge, then the second one is a negative charge. And I want you to be very keen on how the two types of charges are obtained. We are going to begin with a positive charge. How would we obtain a positive charge from a neutral atom? So we said for an atom, number of protons is always equal to the number of electrons. That's what we said. Positives are always equal to the negatives for a neutral atom. So if I have a neutral atom here, like this case, if I can draw, this is the nucleus with 5 positively charged, which we call the protons. And then in the energy level, for it to be neutral, positives must be equal to negatives. So we'll have -5 electrons. Now, in this case, for us to have a positive charge or to charge this atom positively, then it means we must have more positives than negatives. That's when it will be charged positively. Now, how can we make this atom which has 5 electrons and 5 protons to be positively charged or to have more positives than negatives? What you will realize here, the nucleus, we said it's inside the atom and you cannot be able to interact with it. So since you cannot interact with positives, it means you cannot bring a positive and add it there. Therefore, what will remain is the electrons which we can interact with because they are in the outer part of this atom. Now, what can we do to these 5 electrons so that this atom remain with more positives than negatives? Then what you are going to realize is that you can lose. If this one lose 1 electron, it will remain with 4 electrons, but the number of positives will remain as 5. So if now we will have 5 positives and 4 negatives, then this atom will remain positively charged. Now, the one that I've drawn here is neutral. I want to draw another one which now we have lost 1 electron. So if we have the one that we have lost 1 electron, remember protons have remained 5, but now the energy level, in the energy level, we have remained with 4 electrons since we have lost 1 electron. So in this case, we will have more protons, that is 5, less electrons, that is 4. So in this case, we will have it positively charged. And if we want to prove this, we can even add using simple mathematics. Positive 5 plus negative 4. What will you get? This is the same as 5 minus 4. Then we will remain with positive 1. So in this case, if you have more protons than electrons, then it means you will have it positively charged. The net charge, we have more protons than electrons. And if I can write this in a more elaborate way, if you have your 5 positives here, 2, 3, 4, 5. If each positive take an electron that is negatively charged, we only have 4 electrons. The first one will be neutralized, second one will have a partner, third will have a partner, fourth will have a partner. We had 4 electrons only. Then it means the last one will remain without a partner. Now it means this particle will remain with more protons than electrons. And in this case, we will say it is positively charged. Now, how do we form a negatively charged negatively charged particle from a neutral atom? Remember, an atom, we have said number of protons is equal to the number of electrons. Therefore, here in this case, positives is equal to the number of negatives. And now, if we have the same case like this one here with 5, we have an atom with 5 positively charged, then we have 5 negatively charged. In this case, it's neutral. Now, for us to have it negatively charged, it means we will have more electrons than protons. Now, in this case, protons which are positively charged are inside the nucleus. Are we able to subtract? So it means in this case, if we need more electrons than positives, then we need to subtract these positives. Are we able to subtract the positives? We cannot reach them. They are inside the nucleus. So what can we do to this one which we can interact with? What can we do to these electrons so that we have more electrons than positives? Then what we are going to realize is that for us to have more electrons, we will add a new electron. We will take an electron from somewhere and add it here. So in this case, if we bring an electron and add it here, the number of protons will remain 5. But the number of electrons in the outermost energy level or in these energy levels will be 6. If we had 5, we add another one, they will become 6. So we'll have 6 electrons and 5 protons. If I can draw it here, now we will have an atom which looks like this, positive 5. But now the number of electrons in the energy levels are now negative 6. So in this case, we have more electrons than protons. If we can do simple mathematics, positive 5, then plus negative 6. Remember, this is positive 5, positive times negative, negative. So we'll have something like 5 minus 6, which is going to be negative 1. So in this case, the net charge, or what is more in this atom is negative. So the negatives are more by 1. So in this case, we will say it's negatively charged. If I can write it also in a more elaborate way, we have 5 positives, protons like this, and now we have 6 electrons. The first one proton will take an electron, they will remain 5. The second one will take an electron, they will remain 4. The third one will take an electron, they will remain 3. The fourth one will take an electron, they will remain 2. The fifth one will take an electron, because they were 6, it will remain 1. So 1 electron will remain without a partner. Now this electron, the whole of this body will have more electron than positives, and in that case we will say it is negatively charged. So as you can see, in the two cases, for us to charge it positively, we only interact with electrons. We lose an electron for it to become positively. Then for us to charge it negatively, then we add an electron. So in either cases, For you to have a positive charge or a negative charge, what you do, you only play with electrons. If you need it positively charged, you take away an electron, like in the first case here. If you need it negatively charged, you add an electron, like in the second case here. What you should be keen on, we don't interfere with the number of protons. Protons don't move because they are inside the nuclear and the nuclear is very small. It is very hard for you to interact with protons. You only play with electrons. If you need it positively, you take away an electron. If you need it negatively, you add an electron to that neutral atom and it will become negatively charged. So in your chemistry, you will have a specific name for these two, but in general, a positively or negatively charged atom is called an ion. It's called an ion, and we are going to discuss it later. So we have looked at how you can obtain a positively charged atom from a neutral atom, where we have said you take away or you subtract an electron from it so that it has more number of protons than electrons. And how you can obtain a negatively charged particle from a neutral atom, where we have said you add an electron to that neutral atom so that it has more number of electrons than protons. And in either case, you have to note that we either subtract or add electrons. Protons does not take part in either positive or negative charging of a material. So an atom which is positively or negatively charged is called an ion, and you are going to learn specific names for a positive charged ion, which we call a cation, but that one you will discuss in chemistry. And a negative one is called an ion. We are going to discuss more about that in chemistry. Remember, chemistry is related to physics. Another thing that you should note is that the SI unit of these charges, either positive or negative charges, the SI unit is coulomb. And the coulomb is given as simple capital C. And we have multiples and submultiples of coulomb. 1 coulomb is equals to 1000 millicoulombs. And then 1 millicoulomb is equals to 1000 microcoulombs. Therefore, this means 1 coulomb is equals to 1000, that is millicoulomb, times 1000 another millicoulomb for it to make a micro coulomb. So 1 coulomb is equals to 1 million micro coulomb. This is very important. This interrelationship, or there's some multiples of coulomb, is very important. You will need it in the next topic, that what we call current electricity 1. Now, since atoms are very small and we cannot be able to see them, let's move to large materials which we can see and which we can easily observe. If we have rubber, yeah, rubber, remember, is a solid and it's an example of matter. So it has small particles which we call atoms, and these atoms are electrically neutral. It means number of protons is equal to the number of electrons. And then if we have a wool cloth, this wool cloth, and this wool cloth, it also has atoms which are electrically neutral. It means number of protons is also equal to the number of electrons. Now, if you take these two materials and wrap them together, if these two materials are wrapped together, remember, wrapping together, you are causing friction. You are causing a friction, and if you cause friction between two materials, remember, one of the effects of friction is production of heat. And what happens when you increase the heat of particles? Remember, from kinetic theory of matter, we said if heat of particles is increased, the particles will gain kinetic energy. And since in solids, particles are in a continuous vibration, then if they gain more kinetic energy, they will knock each other, and then they will move slightly far away from each other. their movement will increase. If their movement increase and these two materials are in contact, remember when they are in contact, it's only the electrons which are in contact with each other. Since we said protons which are positively charged are inside the nucleus and it's very hard for you to reach them. So when these two materials are in contact, it is the electrons which are in contact. And if the electrons are in contact, these two materials, the electrons will be moving between them, and one material will lose some of its electron to the other material since the movement is very high. And another material will gain the electrons from another material which will lose them easily. So like in this case, if you have rubber and a wool cloth, the wool cloth will lose some of the electrons. So it will lose some of the electrons, and those electrons will move directly to the rubber. And now, if they move directly to the rubber, I can write them here using red as they come. So rubber will have two more electrons. Positives will remain the same. Now, this means the wool cloth will lose these two electrons which it had. I'm going to remove them, these two. So it means now, if we count the number of electrons in the rubber, rubber will have how many electrons? 1, 2, 3, 4, 5, 6. 6 negatively charged. How many protons does it have? 4. 4 positively charged. Then now, if you have negative 6 plus positive 4, what is the answer? Negative 2. So this one will have more negative charges than positive charges. Now in this case, it will remain negatively charged. It means it has more negative charges than positive charges. Now let's go direct to the wool cloth. Wool cloth has lost 2 electrons. How many protons do we have there? We have 1, 2, 3, 4. 4 positives. 4 positives. Then how many negative charges do we have there? 1, 2. We have only 2 negative charges. Then now if we add them, positive 4 plus negative 2, then what we will remain with is 4 minus 2, which is positive 2. So in this case, the whole cloth will become positively charged. This one will become positively charged. So when you wrap two materials together, one of it will gain electron. The one which will gain electron in this case, like in this case here, it will become negatively charged. The one which will lose electron to the other one will have less number of electrons and more number of protons, then it will become positively charged. So for you to charge a material positively, in short, you have to get it lose electrons. And for you to charge a material negatively, it has to gain electrons so that the number of electrons becomes more than positives. Now, another set, if you have a glass rod and far, if you rub the two, the glass rod will become negatively charged. What does that mean? The glass rod will gain electrons. When it gains electrons, it will have more number of electrons than positives, then it will become negatively charged, and then far will become positively charged. What does that mean? It will lose electrons, and then it will remain with less number of electrons than protons, and in that case, it will become a positively charged. So in general, a body is said to be charged positively if it has excess positive charges or it has lost some of those electrons. And a body is said to be negatively charged if it has excess electrons or if it has gained some of the electrons from another material. So if I give you two materials, are you able to charge them positively or negatively? Yes, you rub them together. The one which will gain electrons become negatively. The one which loses electrons become positively charged. So when we talk about electropositivity and electronegativity of materials, electropositivity is a property of a material to lose electrons. And remember, we have said when you lose electron, you will remain with more positive, so you will become positively charged. And electronegativity is a tendency of material to gain electrons. And when you gain electrons, remember we have said you have more electrons and you become negatively charged. So materials which gain electrons easily, we call them, they have high electronegativity and they become negatively charged. So in this case, we have materials like polythene, most plastics, and ebonite. Then we have materials which we call electropositivity. These ones, they lose electrons easily, and when they lose electrons easily, they become positively charged. So an example here, we have acetate, Papex, glass, and far. What you should note here is that whenever you have two materials, and if you bring them together, one of it must lose electrons easily, then the other one must gain electrons easily. So in this case, if you have any two set of materials, then you should be very sure that one must become positively charged and the other one must become negatively charged. The one which becomes positively charged, it means it lost electrons. The one which becomes negatively charged, it means it gained electrons. So that marks the end of our lesson today. In the next lesson, we will look at charging materials, either positively or negatively.